Alright guys, how's it going? My name is Sergey and today I'm gonna talk to you about another different data structure which is called queue. And this data structure in fact is pretty similar to the stack data structure which we were talking about in previous videos, I believe. But it has some differences, of course, some maybe advantages and disadvantages which I'm not gonna discuss here. I'm just gonna show you how to implement this data structure using the C++, I would say, programming language today, and maybe in future videos we're gonna implement the same data structure and related algorithms using, for example, Python or JavaScript, for example, just to add some variety to these tutorials, so that you don't get bored to death by watching C and C++ only, videos. All right. So, and I'm gonna start with absolute scratch, and I'm gonna use Visual Studio Code Editor. Of course, you may use whichever editor you prefer, it doesn't matter really. And I'm gonna quickly explain, I'm gonna quickly show you what the queue data structure is. In fact, it's like standing in a line, I believe. Imagine that you are in a grocery store and you wanna buy some products, and in order to get to the checkouts, first of all you should get to the back of the queue. You should wait until all of the people who are standing in front of you until they are gone, and only after that you are able to get to the checkouts to buy and to buy some products and to pay for them. Alright, so and that's basically it. This data structure follows the principle which is called FIFO or FIFO. I'm not sure exactly how to pronounce it in English, at least, because it's not my first language, but basically it means first in, first out, and the person who or the element which is gonna be put first at the end of the queue is gonna be is gonna be get out, is gonna go out, the first one, unlike in LIFO data structure, where the last element which is going to be put on the top of the stack, for example, will be gone first. All right, so that's the main difference. All right, and as I already pointed out, I'm gonna use the C++ programming language, and I'm gonna comment my code as heavily as possible so that you guys might refer to it later if you want, of course. So I'm gonna say implementing the queue data structure in C++ using arrays. So, and there is a couple of different ways in which you can implement the queue data structure. First of all, you can use arrays, and the second, you might use another linear data structure which is called linked lists, and there are some difference between arrays and linked lists which I'm not gonna discuss here, but basically in a couple of words I would say that linked lists are much more flexible than arrays are, and maybe in the future video I'm gonna explain you the major difference between those. Maybe we might as well implement the same algorithms using linked lists. Alright, but here we want to stick with arrays. Alright, so as I already mentioned, I'm gonna use classes, and I'm gonna create queue class. Alright, I'm gonna say class queue. Alright, and here we're gonna define private and public public and private members of our class. So for the private members, we're gonna say int q. We're gonna represent our q as an array, as I already pointed out before, with the size of size, for instance, and our size we're gonna declare over here, I believe. We're gonna say static constant size, which is gonna be equal to 5, for example. All right, which is gonna be the size of our array. Next, we need as well two pointers, which are gonna be the first pointer is gonna point to the front of the queue, and the second pointer is gonna point to the back of the queue, which we're gonna name, the rear pointer. All right. So, and I'm gonna explain what these pointers are about. Okay. So, and I think that that should do it. Next, I think we can and we should implement our constructor function, public constructor, in order to initialize our queue. I'm gonna say queue, and to get started with our queue is gonna be empty, and if the queue is empty, both pointers, front and rear pointers, they are gonna be equal to -1 to get started with. All right, so we're gonna say front, we're gonna initialize it to -1, and rear is gonna be equal to -1 as well. Okay. Oh, sorry about that, guys. Seems like I made a little mistake. We should initialize our values here like this: front -1 and the rear -1, and the body of our constructor is gonna be it's gonna be empty. All right. So next, we should implement our member functions in order to write some algorithms for the queue data structure. So we're gonna say public, all our functions are gonna be public member functions. Okay. First of all, we should be able to check if our queue is empty. All right. Check if the queue is empty. And here, constructor. We should have said that we should initialize our queue to get started with, I believe. So the queue is empty. As in the beginning. All right. So that looks a little bit better. So first of all, we should check if the queue is empty. Next, we should be able to check if the queue is full. All right. If the queue is full, and the next function which we're gonna implement is gonna be enqueue operation, which means that we should be able to push an element at the back of the queue. Alright, and we can add elements only at the back of the queue, and we can remove elements only at the front of the queue, and that's the main difference from the stack data structure, where we should, I would say, where the first element, which is gonna be put at the top of the stack, is gonna be the first element to be removed from the stack. Alright, and that's the main difference, as already mentioned before. Alright, but anyways, we should be able to enqueue, should be able to dequeue, basically. Operation, and finally we should be able to print the queue onto the screen, I believe. Alright, so that's our strategy. Let's write some functions. So first of all, we should check if our queue is empty, and this function is going to be the type of bool. It's going to return true or false. It's going to return true if our queue is empty, and it's going to return false otherwise. Alright, check is empty, I believe. You can say is empty. Alright, and as I already pointed out before, our queue is empty if the front and rear pointers are going to be equal to -1. So we're just gonna say front, if the front pointer is gonna be equal to -1, and the rear pointer is gonna be equal to -1. If they are both true, that means that we return true, right? And otherwise we're gonna return false. Alright, easy peasy. Alright, so next we should be able to check if our is gonna be the type of bool as well, if our queue is full. Okay, so the queue is full if the rear pointer is gonna be greater than the front pointer. So and I'm gonna explain why this is the case a little bit later when we are implementing the enqueue and dequeue operations. Alright, so we're just gonna say for now, if front is equal to 1, is equal to not 1, if front is equal to 0, that means that there are some elements in our queue, and the rear, sorry about that guys, no, I'm mistaken. We're gonna say if front is gonna be greater to the rear, that means that the queue is empty, the queue is full. Alright, return true, otherwise we should return false. Okay, yeah, if front is greater than rear, yeah, that means that we reached the end of the queue and our queue is empty, and yep. No guys, seems like yes, I must have been mistaken. Sorry about that guys. here we should have said that yeah, if front is greater than rear, that means that our queue is empty as well. All right, because this way we have removed all the elements from our queue. Yeah, I mean, yeah, stupid me, sorry about that, guys. Here we should say if rear is gonna be equal to the size, okay, to the size of our array, okay, size yeah, if the array is gonna be equal to the size minus 1, so that means that our array is full, and the front pointer is equal to 0. Alright, that means that our queue is full. Alright guys, yeah, that should do it, I believe. Yeah, next we should be able to perform enqueue operations. Okay, we're gonna say void enqueue, I believe, and we're gonna push some data, or I believe element, we should call it. All right, so first of all we should be able to check if the queue is full. So if the queue is full, that means that we are no longer able to push new elements into the queue. All right, if is full, all right, that means that we're gonna tell the user that the queue is full. All right, so yeah guys, I should have included a couple of directors over here, up here I would say. Include IOStream. Alright, and that should fix our little mistake. Alright, so otherwise, if it's not full, so what's our strategy, right? So if it's not full, we're gonna increase the rear pointer by 1. Okay, we should be able to say rear. First of all, should be able to increase the rear pointer by 1, so that we'll be able to, to push new elements at the back of the queue. All right, that's why we're increasing the rear pointer by 1. So, and we're gonna say rear plus plus. Okay. So what are we gonna do next? Next we should be able to we should be able to say to increase our rear pointer by 1, as I already pointed out before. Next we should set the front pointer to 1, to 0, right? Because at the beginning the pointer was -1. Okay, and we should set the front pointer to 0 while we in queue. Okay, so we're just gonna say front equals to 0. All right, and the last last but not least, of course, step would be to put a new element at the back of the queue. At the back of the queue, at the pointer, at the index pointed to by rare, I believe. Yep. So we're just gonna say so we're gonna say queue rare, alright, is gonna be equal to the element that's passed in here. Alright guys, and I think that should do it. So the next operation will be the dequeue operation. So we're gonna say void dequeue. Yeah, I think we can return. Yeah, here I think that we should return the popped, not the popped, yeah, the popped element of the queue. So the return time is gonna be integer. We're gonna say dequeue, and yep. So first of all, I should be able to check if the queue is empty, so that if the queue is empty, there's nothing to be deleted, right? I'm gonna say if is empty. So we're gonna say stdc out, the queue is empty. Okay, and we're just gonna need to return, and here we need to return as well, I believe. Return. Alright, so else, so what are we gonna do otherwise? Alright, first of all, we should display the pop element from the queue. Okay, so we're just gonna say std out the popped element and the popped element is gonna be, you know, the front element, I believe, of the queue. Yep, front. Alright, and the next we should increase increment the front by 1, so that we be able to move traverse, I would say, traverse the queue. Alright, the queue towards the end. Okay, so I'm gonna say, yeah, I think that here we should have declared variable of the element, for example, which we're gonna put into our popped element here. I think that we should have set element gonna be equal to Q front. Here we're gonna return -1, I believe, so if it's empty. Okay, but we should return an integer value. Alright. Alright, and here we just put an element, the popped element right here. So we're gonna increment front by 1. Front plus plus. All right. Yeah, guys, and here we should check a couple of cases before displaying the popped element. I think that we should say if we should check if we should say if front is gonna be greater or equal to the rear. That means we reached the end of the queue, and we should reset the queue. Alright, so that means that here, not here, so that, guys, so I haven't just been planning this video, and I'm doing it as I move on, right? So about that, guys, if front is gonna be greater or equal to rear, that means that we reached the end of the queue and we should reset the queue. Okay, we're gonna say front is equal to rear, it's gonna be equal to -1, like this. Okay, so we're gonna say else front plus plus. All right, so yeah, and after that we should be able to display the popped element, and also I'm gonna say I'm gonna put this comment here. Alright, so sorry about that, guys. The code is becoming a little bit messy. Alright, I apologize, and we just return the element. Alright, yeah, I think that should do it. Alright, alright, guys, we have only one function left, and we'll be able to ready to test our little algorithm. Alright, so we're gonna say print q. Okay, so we're gonna print the q using for loop, I believe. Print all the elements of the queue on each iteration, I believe. Right? So we're gonna say DC out the queue. Alright, we're gonna say for int I is equal to the front, starting from the front. I is less than or equals to the rear, and I'm gonna say I plus plus like this. So we're gonna stdc out q, alright, I like this. We're gonna put space here, and we need to put a new line after we're done. Line, okay. And yeah, guys, I think that should do it, and we can start implementing, we can start testing our algorithm in C++. Alright, so we're gonna say int main, alright, return 0. So we're gonna instantiate our class, create a new object, instantiate a new q object. Alright, we're gonna say q, they're gonna be the type of q. So, and it's gonna be empty by default, because our constructor is gonna put it to an empty queue. Alright, it's gonna set it to an empty queue. Okay, like this. Alright, next we're gonna enqueue a couple of elements in queue. So maybe 10. Queue a couple more elements. 30. 50. Alright, and now we can, I want to display our elements of the queue. Okay, queue print queue. So now we're gonna test our program. Alright, I'm gonna say g++ q arrays cpp. Yep, seems like we don't have any mistakes, which is a good sign by the way. Alright, we're gonna run the program. The queue is 10, 20, 30 and 50. So the first element 10, which is at the head of the queue, and the 50 is the last element, which is at the back of the queue. Seems like this method of enqueuing is working correctly. So perfect. Now we wanna the max size of our queue is, remember, the maximum size of our queue is 5. Alright, so let's pretend that we wanna push a couple more elements into our queue, and we should receive Stack Overflow. Alright, not Stack Overflow, I think that we should receive an error. Alright, some kind of error. Enqueue 70, for instance. So enqueue, not the queue. So that, guys, enqueue, enqueue. Okay, we're gonna compile the program and we're gonna run it. Yep, we only see the 5 elements of our queue, and the 6th element hasn't been put at the back of the queue because our queue is full. Alright, perfect. Now we wanna say we wanna dequeue our queue. We're gonna say dequeue a couple of times, dequeue, and we're gonna check it out. We're gonna compile and we're gonna run our program. Alright, so seems like we're having a little issue over here. I think adopt element. I think that we should put a new line here. Sorry about that, guys. Yep. So let's recompile the program. Let's recompile it one more time. Let's run it. Alright. And we didn't print the queue after we have dequeued our queue. Alright, we're gonna say queue print queue. Okay, here I'm just comment my code a little bit. Print the queue. Alright. Printing the queue one more time. Print the queue. Alright. So let's compile the program and run it. Yep. And 10 and 20 they were removed from the queue, from the head of the queue. Alright. So they were the first ones to be put at the front of the queue, and they were as well the first elements to be pushed out of the queue. Okay, seems like our algorithm is working, and so let's dequeue our queue a couple more times, so that I want to make sure that when the queue is empty, we won't be able to dequeue anything. Alright, dequeue, okay, and yeah, I think that should do it. Let's compile it and run it one more time. The queue is empty. Yep. Seems like our little algorithm is working, and yeah, I think that should do it. It was quite a bit of code, I believe, and yep, I think that in the next video I'm gonna explain to you guys how to implement this very algorithm using Python, maybe. And by the way, in Python and in JavaScript, for example, these algorithms, the implementation of these algorithms are going to be much easier, because first of all, in Python, for example, in particular in Python, we have a data structure which is called a list. Okay. Which is able to keep the track of its size automatically. That's why we don't have to care about the size of our queue beforehand. All right, and we instead we should only care about the fact if the queue is empty, and that's it. We don't care about if our queue is full, because as I already pointed out before, in Python the structure is very smart, and as well as in the same can be applied to other more modern programming languages, such as Java, for instance. I believe, and JavaScript, of course. But yeah, I think that we can stop here. Thank you guys a lot for watching this video. Hopefully you have learned something for your that might be useful and applicable to what you are doing at the moment. No, but if it's not applicable to your current job position, but I think that anyways you enjoyed it a little bit, and I sincerely appreciate every one of you who watches my videos, because your time is priceless, your attention is precious, of course, and everybody has his or her own responsibilities. Not everybody is able to to dedicate some time, some free time to watching 30 or 40 minute videos, especially not which are not very polished. So let's be honest, my videos are not very polished. They are not planned beforehand carefully. To be honest, I don't have too much free time to to dedicate myself completely to tutorials and things like that. But anyways, I am trying to do my best in order to please you guys, so that if something was a little bit off, and a little bit wrong, sorry about that, guys. I apologize beforehand. Yeah, and hope you are guys doing well. I hope you all the best, and yeah, so